So we're going to start off the proof of even and odd functions in a kind of slightly different way. I haven't given you a formal definition of what an even function is yet, or what an odd function is yet. I suppose I'll do that now. But an even function is one in which its value of x, f of x, so the y value, is the same as the y value if x was a negative input. So whether it takes a positive x or a negative x as the input, it gives the exact same output. So this is what we would call an even function. Now, for an odd function, you get something slightly different. If you have a negative input, you would have the same y value, except it would be a negative value. So it would be seen as not necessarily a reflection across the y-axis, but a rotation. Perhaps the easiest way to see that is to see the first odd function that we've ever seen. That's our straight line, the line y equals x. Now that's an odd function because you can see if I have a point at f of 2, and I'll just draw the coordinate there, 2 and f of 2, you'll see its coordinate is up here, so its y value is 2 above. Now if I did negative 2 and f of negative 2, you would see going x units in this direction or x units in that direction leaves the same magnitude of the y value, but the opposite sign. So it's as if this piece has been rotated over. Now it's tough to see visualization of rotation with a line, but if I change it to another odd function like a cubic, it becomes even easier to see. Now so that we can get our points back on the line, I'm going to take our cubic and compress it, but you can see we've got the exact same spots. So this spot has been rotated over, and you can see the entire branch. And I'll perhaps split this into two regions, one where x is greater than 0. Well, that's not how I do that. I do it like this. X is greater than 0. That's not how I do that. Sorry, the bugs are getting bad out here. X is greater than 0 is how I do that. Yep. And then I can do another one with the exact same function. Of course, I'll change its name to where it's less than 0. And then that way you can see that this arm has really been rotated over. And if I just change this to G, this point got rotated over to here. So that's an odd function. All odd functions, that's a big B. All odd functions are the same in that they're rotated about that, which means they either have to include the origin as a point. Mine doesn't because I don't have a greater than or equal to sign. There, now it does. So it has to include either the origin as a point or the origin has to be a point restriction. So let me change this back to f and I'll show you another odd function. So another odd function would be like 1 over x. So this is an odd function. You can see that everything from the right upper quadrant, or quadrant 1, has been rotated down into quadrant 3. If I go across 2 units, I have to go up a half a unit. Whereas if I go back 2 units, I have to go down a half a unit. So this purple point has become the black point when we consider rotation. So that's an odd function, what it looks like graphically. Here's an even function. So for an even function, there's no rotation, but rather there's a reflection. So if I go to the line x equals 2, and if I go to the line, so let's just do a, and x equals negative a. Ooh, this is fun. Why did it do that? A should be a constant. I must have defined a. So x equals b. B equals 1. Sorry, for some reason it's not letting me do sliders very effectively, so I'll just do it like this. Oh, there we go. I got sliders. Neat. So you can see if I go to this point, 2 over, I have to go up 4, and if I go 2 back, I have to go up 4 as well. And there's that symmetry as we go back and forth. And so this is what we would call an even function. It's even because of the fact that, get rid of the text for it to show back up again, because of the fact that it's reflected across the y-axis. Now, an even function does not have to include the origin, because we can see, even if this is translated up 1, that property of going to the right and to the left and searching for the same y value exists. And that means that there doesn't have to be the origin. So now I think we can take a look at some of our trig functions and ask whether they're even or odd. So let's define, I don't know, sine of x. Now, this isn't particularly a good axis. I prefer looking at an axis going from 0 to pi to 2 pi. So I'm going to change my x-axis scale from negative 2 pi to positive 2 pi. And I'll just change my step to pi by 4. And I'm going to change my y scale because I know it has a range of negative 1 to positive 1. So I'll go negative 2 to positive 2 just so everything kind of pops. So here we have our sine graph. And let's plot the point, I don't know, a and f of a. And then let's also plot the point negative a and f of negative a. So now, as I move this point a around, so there it is at 0, containing the origin, as I move it out, and you can see the red dot moving to the right, the green dot moves the same distance out and down. So these points are mirrored, moving away from the origin. This is exactly the behavior that you would expect to see in an odd function. So graphically, sine is odd. Now, what implications does that have? Well, it means if you knew sine of 45 degrees, I should do the sine of radians. Let's do sine of pi by 4. And that's 1 over root 2. And now if we did sine of negative pi by 4, well, it's going to give us the exact same answer except for negative. And this can be useful when solving for some particular values because you know there's that type of symmetry that exists. Now that's for a sine function. Perhaps I should take a look at another function. So I will. I'll get rid of these calculations here and maybe hit pause and make a prediction. What do you think? Is cosine going to be even or odd? Just picture the graph in your head. And yeah, it's got to be even. And you'll see that it is even. It's a perfect reflection across the y-axis. As I start moving away with the red dot to the right, the green dot is at the exact same height. And I can actually plot that height there so we can see it. So I will consistently stay at the exact same height with the green dot and the red dot as I move away. So that classically shows that cosine is going to be an odd function. So what implications does that have? Well, it means that cosine of literally anything, so type any number you want, 105, even though we're in radians, it doesn't matter. That's going to be the same as cosine of negative 105. Or cosine of pi, which we all know is negative 1, it's going to be the same as cosine of negative pi. Now, why does that last one make good sense? Well, it makes really good sense because if we go pi units around the unit circle, we end up on the x-axis toward the left. And if we go negative pi units, well, we're just going down and back to the x-axis on the left. So it should be the exact same value because we've gone half of a rotation either counterclockwise in the positive sense or clockwise in the negative sense. So those are even and odd functions.